Okay, the next section we're looking at deals with formalizing relations and functions. So hopefully at the end of this, you can say that I can determine whether a relation is a function. I can use a vertical line test to determine whether a graph represents a function, and I can find the domain and range of a function. So first of all, determine whether a relation is a function. First of all, what is a relation? It's pairs of numbers, similar to like a relationship in real life. You got a pair of people, would be a relationship. So that's similar to what a relation is. So we're trying to determine whether it's a function or a functioning relation. So what are the ordered pairs here? If I said this is my t-chart, hopefully we can realize that my ordered pairs would be a -1, 6, a 0, 5, a 2, 8, and a 2, -6. So hopefully we can be able to determine some ordered pairs just from tables. That's the first thing we want to be able to do. Next thing is we gotta look at a little story. So my story is about double standards. So in our society, there's a double standard. And the double standard is this. If a boy is in a relationship with a girl and he decides to uh, cheat on his girlfriend, his friends, his buddies, would be all excited because that boy is a player. He's working it. So, can boys cheat on their girls? The answer in our society, uh, well, as the double standard, oftentimes is yes. However, if we look at it on the flip side, if a girl is in a relationship with a guy and she decides to cheat, uh, I can already hear the names that you're saying. Hopefully you didn't say them out loud, but those girls are not thought of very kindly. So can girls cheat on their guys? The answer is a resounding no. So we are going to look at the girls in these functions as the x's and the guys in these t-charts as our y's. So girls are the x's, guys are the y's. So this is what we're looking at. So if we look down this set of ordered pairs, which is a relation, and we're trying to determine whether it's a function, okay? We've got a -1 with a 6, which is -1 is the girl, y, or the 6 is the guy. We got a 0 with a 5. We got a 2 with an 8. We got a 2 with a -6. So hopefully we can see down here, we got this girl, this 2, who is cheating. She is with an 8 and with a -6. This, my friends, is not a function. That girl is cheating. No good. Okay? If we look at the second one, and I looked on that X column, is there any girls that are with two different guys? And the answer here is no. I've got a 1 with a 5, an 8 with a 2, a 3 with a 7, a 6 or 2 with a -6. This here is a function. No girl is cheating. Okay, if we look at the next one, we got an 8 with a -2, we got a 3 with a 5, we got a -9 with an 8, we got a 7 with a 5. Once again, this is a function because there is no girl that is cheating. Okay, if we look at the next one, if we want to know is it a function or not, next one we got 5 with a 1, a 3 with a 5, an 8 with a 7, a 5 with a 1. So first thing you're thinking is this. We got a 5 showing up twice. That's not good. That girl is cheating. However, this is like saying the girl was seen with a 1, and then later on was seen with the same 1 again. So this still is a function. The girl is seen with only one guy. The next one, if we look to this one, we got 2, 8, a 5, 8, a -3, 8, and a -6, 8. Some of you are saying, well, there's a lot of cheating going on. However, remember, this is a Y, which is a guy. In our society, that guy can cheat on his girls. and this would still be a function. I don't condone this behavior, but that's our double standard. Okay, next one. Let's determine. So a formal definition of what a function is this. For every x, there is exactly one y. So is it a function in y? Let's look at this first one. We got a negative 7, 1. We got 3, 2. We got a 9, negative 5. We got an 8, 3. Is there any cheating going on? And the answer would be no. So it is a function. And how would I explain it? Every x has exactly one y. Okay, next one, we got 2, 4, we got a 5, 8, we got negative 3, 4, we got 2, 8. Okay, so what's the problems? Well, the only problem is this 2. Some of you might have been looking at these 4s and these 8s here, but however, the only problem is the 2s. So this is not a function. You could describe it saying the 2 has different y's. Okay, so that would be a good reason to describe why it's not a function. Okay, so if we had to look at these ordered pairs and determine there if they're a function or not. Okay, so if I were to look at number 1 down here, if I were to just spread it out a little bit, 4, 5, 8, 1, negative 3, 7, and 5, 8. If I stack them up, sometimes it's easier for me to tell. And in this case, there's no cheating, so this one would be a function. Okay, if I looked at the second one and I stacked them up, this time I got a 3, 7, I got a negative 5, 4, I've got a 2, 7, and I've got a negative 4, 5. And is there any cheating? Well, there's some cheating. The 7 was with a 3 and with a 2, but that's a guy, so this is still a function. Okay, the third one, we got a 6, 2. We got a 4, negative 3. We got a 5, 2. We got a 4, negative 9. And is this one a function? And hopefully we're saying no because of that 4. So this is not a function. Okay, moving right along. Next thing we want to look at, if we looked at graphs, if I were to plot these points on a graph, I've got a negative 2, 6, a 0, 5, a 2, 8, and a 2, negative 6. Okay, first of all, I hope we can see that this is not a function because of these 2's. And when we graph it, hopefully we can see that when we graph them, they end up being stacked on top of each other. Okay, so that would mean it's not a function. Okay, if I look at this one, that's actually the exact same one. I don't want to look at the same one twice. Okay, if we looked at this one, we got a negative 3, 5. We got a 4, 5. We got a negative 3, 8. We got a 1, negative 6. Okay, and once again, hopefully we can see that these two right here tell me it's not a function. If I'm looking at it graphically, again, they're stacked on top of each other. Okay, this one here, hopefully we can see right away, not a function. If I were to graph it, I would have a negative 3, negative 3, 6. I got a 2, 5. I got a 2, 8. I got a 1, negative 6. Okay, and again, hopefully we can see that these two right here are stacked on top of each other. It's not a function. Okay, we're going to flip through here. So the idea that we want to look at is that if we are looking at a graph, we can use a vertical line. If that vertical line passes through more than one point, then it is not a function. So if I scoot ahead here and I say, is this a function? I can grab this vertical line and I can slide it through, and if it hits more than one point at a time, it's not a function. So in this case, it never did, so this is a function. Okay, if I looked at this one and I pull my vertical line through it, hopefully we can see right here that it hits. So this one is not a function. That vertical line hits more than one point. Okay. Next one. If I drag my vertical line through here, hopefully you can see that dragging it through, it's only going to hit one point at a time. So this one here is a function. Okay. This one, drag it through here. Hopefully you can see there's lots of places where it's going to hit more than once. So this is not a function. Okay, this one. If you slide this one over and we stop right here, hopefully you can see that there's all kinds of points that it's hitting. So this cell as well is not a function. Okay. A couple other words that we got to think about or know. The domain is going to be our x values. The range is going to be our y values. So if I ask you to identify the domain and range, the domain of this relation here is just all of the x values, the 4, the 8, -3, the 5. The range are the y values. So that would be the 5, the -1, the 7, and the 8. You don't need the parenthesis here. Okay, I'm just going to look at number 3 here quick. 3, the domain would be the 6, the 4, the 5, and the 4. The range, and I should mention you don't need to say 4 twice. Okay, the range would be a 2, a -3, we got another 2, and a -9. Okay, domain and range, we just got done doing that, determine whether it's a function or not. So you'd pick out the domain. It's 2, 8, 9, 4. The range is a 4, 11, 1, 2. If we wanted to know if it's a function or not, you could stack them up. 2, 4, 8, 11, 9, 1, 4, 2, and determine if you got any cheaters. And you don't, so this is a function. Okay, you could do the same thing for the next one as well. And we just have a couple more examples. So I'm going to leave it at that. Hopefully you got the notes. If not, again, you can stop and rewind it.